Good morning, dear students. Welcome back to physics class. In today's class, I would like to teach you new topics. They are speed of a flux, Torricelli's law, and Venturi meter. Let us discuss on the topic speed of a flux of a fluid and its related law. It is Torricelli law. What is the meaning of efflux? Efflux means outflow. The Italian physicist Evangelista Torricelli discovered that the expression for speed of fluid efflux from an open tank is similar to the expression for speed of a freely falling body. How can we verify this? You know that the speed of a freely falling body v is equal to root of 2gh, as v square is equal to 2gh, and initial velocity u of a freely falling body is always equal to 0, which was studied in 9th grade class when you met three equations of motion of an object which is under the action of gravity in two cases. In first case is the vertically projected body, and in the second case it is the freely falling body. It is the velocity v is equal to root of 2gh, where v be the final velocity or the velocity of the freely falling body when it just touches to the ground, and h be the distance or vertical distance traveled by the body. So, we have to prove the speed of the fluid efflux v is equal to root of 2gh. Let us see the statement of Torricelli law. Torricelli's law states that the speed of outflow of a fluid from an open tank is equal to the speed that it would attain if falling freely for a distance equal to the height of the free surface of the fluid above the open tank. It means the speed of the outflow of the fluid from the open tank is equal to the final speed of a freely falling object when it travels the distance equal to the height of the free surface of the fluid above the open tank. Consider any vessel which has a slit or a side tube filled with some fluid. The fluid will start flowing through the slit, and according to Torricelli's law, the speed with which the fluid will flow is equal to the speed with which a freely falling body attains, such that the height from which the body falls is equal to the height of the slit from the free surface of the fluid. Let the distance between the free surface and the slit be h. Again, from the statement of Torricelli's law, it is clear that velocity with which the fluid flows is equal to the velocity with which a freely falling body attains if it is falling from a height h. Now, you are going to see how to derive Torricelli's law, which can be derived by using Bernoulli's principle. Let A1 be the area of the slit. It is very small. V1 be the velocity with which the fluid is flowing out. A2 be the area of the free surface of the fluid, and V2 be the velocity of the fluid at the free surface. We know that AV is equal to constant by equation of continuity. then we can write as A1 V1 is equal to A2 V2. From the given figure, you have seen that A2 is very greater than A1. Then this implies that V2 is very less than V1. This means that the fluid is at rest on the free surface. Therefore, the velocity V2 is approximately equal to 0. Then, by applying the Bernoulli's equation at the slit, we get Pa plus 1 by 2 rho V1 square plus rho G Y1, which is the expression 1. Here, P is replaced by Pa and H1 is replaced by Y1. As the slit is opened to the atmosphere, the pressure at this point will be Pa instead of P1. And Y1 be the height of the slit from the bottom of the vessel. By applying Bernoulli's equation at the free surface of the fluid, we have P plus rho G Y2, which is the expression 2, where V2 is considered to be 0. Therefore, 1 by 2 rho V2 square is equal to 0. And Y2 be the height of the free surface of the fluid from the base. We have the expressions 1 and 2. They are Pa plus 1 by 2 rho V1 square plus rho G Y1 and P plus rho G Y2. By equating the expressions 1 and 2, we get Pa plus 1 by 2 rho V1 square plus rho G Y1 is equal to P plus rho G Y2. Then 1 by 2 rho V1 square is equal to P minus Pa plus rho G Y2 minus Y1, which is equal to P minus Pa plus rho G H, where Y2 minus Y1 be H, which is the height of the slit from the bottom surface of the vessel. Then V1 square is equal to 2 by rho into P minus Pa plus rho G H. Therefore, V1 is equal to square root of 2 by rho into P minus Pa plus rho G H. This is the velocity by which the fluid will come out of the small slit. So, V1 is known as speed of efflux. This means the speed of the fluid outflow. Let us see two different cases. Case 1. The vessel is not closed. It is open to atmosphere. That means P is equal to Pa. We have the expression V1 is equal to square root of 2 by rho into P minus Pa plus rho G H. Since P is equal to Pa, the expression will become as V1 is equal to square root of 2 by rho into 0 plus rho G H is equal to square root of 2 by rho into rho G H is equal to square root of 2gh. This is the speed of a freely falling body, which is in accordance to Torricelli's law, which states that the speed by which the fluid is flowing out of a small slit of a container is equal to the speed of a freely falling body. And case 2 is the tank is not open to the atmosphere. Here P is very greater than Pa, so Pa can be neglected. Therefore, rho GH is also ignored as P is very large. Hence, V1 is equal to square root of 2P by rho. Then, from the common expression for V1, we get V1 is equal to square root of 2P by rho. This kind of situation occurs in rocket propulsion. The expression V1 is equal to square root of 2P by rho shows that the velocity with which the fluid will come out of the container is determined by the pressure at the free surface of the fluid alone. How can we measure the speed of incompressible liquid? It is the device which is called venturimeter used to measure the liquid flow or the speed of the fluid. It consists of a tube with a broad diameter having a larger cross-sectional area, but there is a small constriction in the middle. It is attached to U-tube manometer as shown in given figure. One end of the manometer is connected to the constriction and the other end is connected to the broader end of the venturimeter. The U-tube is filled with fluid whose density is rho. Let A1 be the area of cross-section at the broader end, V1 be the velocity of the fluid at this end. A2 be the area of cross-section at the constriction and V2 be the velocity of the fluid in this middle region or the constriction. According to the equation of continuity, the area is more, velocity is less, and area is less, the velocity is more. When A1 is more than A2, this implies that V1 is lesser than V2. As pressure is inversely proportional to velocity, therefore at A1, pressure P1 is less as compared to the pressure P2 at A2. This implies when P1 is lower than P2, then V1 is greater than V2. When A1 is more than A2, this implies that V1 is lesser than V2. As pressure is inversely proportional to velocity, therefore at A1 the pressure P1 is more as compared to the pressure P2 at A2. This implies that P1 is greater than P2 when V1 is lower than V2. Schematic diagram of venturimeter is shown in given figure. Let V1 and ρ1 be the speed and density of the liquid at the area cross-section A1 and V2 and ρ2 be the speed and density of the same liquid at the area cross-section A2. Since the liquid is incompressible, ρ1 will be equal to ρ2. As there is difference in the pressure, the fluid moves. This movement of the fluid is marked by the level of the fluid increases at one end of the U-tube. By the equation of continuity, A1 V1 is equal to A2 V2. This implies V2 is equal to A1 by A2 into V1, which is the expression 1. According to Bernoulli's equation, P1 plus 1 by 2 rho V1 square plus rho g H1 is equal to P2 plus 1 by 2 rho V2 square plus rho g H2. As height is same, rho g H1 is equal to rho g H2, which are cancelled in the expression. Then P1 minus P2 is equal to 1 by 2 into rho into V2 square minus V1 square. By using the expression 1, we can write the expression for P1 minus P2 as P1 minus P2 is equal to 1 by 2 into rho into A1 square by A2 square into V1 square minus V1 square. As V1 square is common, we can write the expression as P1 minus P2 is equal to 1 by 2 into rho into V1 square into A1 by A2 the whole square minus 1. You should see that as there is change in the pressure or there is a pressure difference, the level of the fluid in the U-tube or the manometer changes. We know that P1 minus P2 is equal to H rho m G, where rho m is the density of the fluid inside the manometer. Then we can write as P1 minus P2, which is 1 by 2 rho V1 square into A1 square by A2 square minus 1 is equal to H rho m G. Then what is V1? V1 is equal to square root of 2H rho m G by rho into A1 square by A2 square minus 1 the whole raised to minus 1 by 2. This is the required expression for the speed of liquid at the area of cross-section A1. If you know the value of V1, you can find the value of V2 at the area of cross-section A2 by using the expression 1 as V2 is equal to A1 by A2 into V1. The practical applications of venturimeter. The devices such as the carburetor of automobile, atomizers, sprayers and Bunsen burner work under the principle of venturimeter. In the carburetor of automobile, there is a venturi channel or nozzle through which air flows with a high speed. Then the pressure is lowered at the narrow neck and the petrol or gasoline is sucked up in the chamber to provide the correct mixture of air to the fuel, which is necessary for the combustion of the fuel. The other devices such as Bunsen burner, atomizer, gun sprayer, etc. also work under the same principle of the venturimeter. How does a spray gun work? Consider a bottle filled with the fluid and having a pipe which goes straight till constriction. There is a narrow end of the pipe which has a lower cross-sectional area. The cross-sectional area of the constriction, which is at middle, is less. There is a pressure difference when you spray. As a result, some air goes in. You see that velocity of the air changes depending on the area of cross-section. And also, because of the difference in the area of cross-section, there is a pressure difference, then the level of the fluid rises and it comes out. Dear students, today's homework questions are given in this slide. Please, you have to work out these question answers by today itself. Okay, thank you. Have a nice day.